Hello everyone, myself Vinay Kumar M. In this channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my last video, I was covering coal and petroleum, the third chapter of science subject in 8th standard. Today I'll be doing chapter 4, that is combustion and flame, of the same science subject in 8th standard. So in this chapter, you have two concepts, that is one is combustion and the other is flame. Coming to the first topic in this chapter, that is combustion. What do you mean by combustion? So whenever any object or any substance which burns with the oxygen, presence of oxygen in the atmosphere is known as combustion. Any substance like coal and wood, if it burns with the presence of oxygen in the atmosphere, then that kind of process is known as combustion. So these kind of things which burns in with the help of oxygen and gives the heat energy outside, so these kind of substance are known as fuels. So when fuel is burned in the presence of oxygen, we get flame, we get heat energy. So that kind of burning of that fuel in the presence of oxygen is known as combustion. So here the carbon content which is present in this coal and the carbon content which is present in the wood actually reacts with the oxygen. So the carbon element present in these kind of fuel will react with the oxygen present in the atmosphere, and these two combine to form CO2 and CO. So whenever you burn coal or wood, you will see that release of carbon dioxide and carbon monoxide into the atmosphere. That shows carbon is actually reacting with the oxygen, and while carbon and oxygen, when it is combining to form CO2 and CO, in the process of combination, the energy which is released is heat energy. So the fire which you see when you burn coal and wood is actually the heat energy and light energy which is emitted from that particular substance, because the carbon present in that particular substance is actually reacting with the oxygen and they are actually forming carbon monoxide and carbon dioxide and releasing into the atmosphere. So the combination of two atoms, carbon and oxygen, releases the energy into the atmosphere, and we can utilize this heat energy and light energy for our various other energy requirements. So here you should remember the words fuel, you should remember the word combustion, you should remember the word oxygen and how carbon react with this oxygen molecule to form carbon dioxide and carbon monoxide, thereby giving us heat energy and light energy. So these all keywords which is present in this particular topic, so you should remember all these keywords. So to understand how carbon is actually reacting with oxygen, we can do an experiment at home. So when you light up a candle on the surface, and if you close this candle with a glass cup, so at that time you can see that the candle which was kept outside the glass cup was actually burning and giving out the flame. But when this candle was covered with the glass cup, suddenly the flame of candle extinguishes, because when you close this glass cup on top of the candle, there will be lack of availability of oxygen. So when there is lack of oxygen, the carbon which is present on the tip of this candle will not get enough oxygen to burn. Hence thereby the fire which was there on this candle will actually get extinguished. So this experiment shows you how oxygen is very much important to burn a candle. That is, when carbon is there in that particular substance is actually getting reacted with oxygen to give out the flame, and this flame gets extinguished when there is lack of supply of oxygen. So you might have seen some human beings, when they catch up fire accidentally, the fire which is catch up on this human being will be extinguished by closing this human being with the blanket. So when the blanket is covered across the human being who will be burning with fire, so at that time, due to the lack of oxygen, the fire which was catch up by a human being will get extinguished and that human being can survive. So in this experiment also you can see that how oxygen is playing a major role in burning things. There is one more keyword in this topic, that is known as ignition temperature. So at a particular temperature, a substance catches fire. That means if you keep a coal piece here, so this coal piece has a certain amount of ignition temperature. So if that temperature is reached for this coal, then this coal starts burning. That shows above a normal temperature, this coal starts burning. Other than coal, you can take example of so many other elements as well. If you consider petrol, petrol has very less ignition temperature. That means even with less temperature, petrol actually catches fire. So petrol has very least ignition temperature. Similarly, any other objects have different kind of ignition temperatures. So when the temperature of that particular object, when it reaches the ignition temperature, then only that particular object catches fire. So the temperature point, the lowest temperature point at which an object catches fire is actually known as ignition temperature. If you take rock or if you take iron, that has very large ignition temperature, because you can see that with normal fire this iron and stone cannot be burnt. So they require lot of temperature, lot of energy should be spent to burn that rock and to burn that iron. So that shows iron and rock has very much higher ignition temperature, and petrol, coal, diesel, like these petroleum products have very less ignition temperatures. As I discussed in my previous chapter, coal and petroleum products are actually used as a fuel for various other fulfillment of energy requirements. So that shows, because coal and petroleum products have very less ignition temperature, so by spending little energy we can easily burn out this kind of petroleum products and coal, so that we can get lot energy, and that energy can be used for various other purposes. So you might be using matchsticks in your home for lighting various other things. So what does this matchstick end contains? Like you can see a black color part is actually stuck to the end of this matchstick. So this black color end of the matchstick contains antimony trisulfide, potassium chloride and white phosphorus in olden days. This antimony trisulfide and potassium chloride actually reacts together and hence combustion happens. So for this to give enough heat energy, this white phosphorus was actually used. So when this matchstick is actually rubbed against the rough surface of the matchbox, that rough surface will give enough heat, that rough surface give enough temperature, that is known as ignition temperature. So that ignition temperature of white phosphorus is just reached when you rub this matchstick against the rough surface of this matchbox. So because of that, the heat which is generated by rubbing the matchstick against the matchbox will actually combust this white phosphorus, and hence makes potassium chloride to react with antimony trisulfide, and hence the combustion happens and flame is produced. Later on it was proved that white phosphorus is very much dangerous for the workers who are working in the factories, and also white phosphorus is very dangerous for people who are using it. So that's why they actually replace this white phosphorus with red phosphorus, where red phosphorus, after when you strike the matchstick against matchbox, will get converted into white phosphorus, and then it gives the necessary energy for potassium chloride to react with antimony trisulfide, and hence the combustion process happens. Because of that combustion, the flame is produced on the matchstick, and you can use that flame for burning various other things. This is actually the science behind the matchstick. Here actually white phosphorus or red phosphorus, which are used in matchstick, have very less ignition temperature. Because they have very less ignition temperature, hence they catch up fire immediately. You might have seen in your home, when you heat the oil for longer time on the gas stove, then this oil suddenly starts catching fire. That shows the temperature of that oil has reached the ignition temperature, and hence the oil starts catching fire. Similarly, if you take kerosene as your example, then kerosene which is kept at room temperature, that is at 25 degrees Celsius, kerosene will never get combust. But when you increase the temperature, that is when you supply sufficient amount of heat for this kerosene, then this kerosene actually catches fire. That shows when a certain amount of ignition temperature for this kerosene is reached, then this kerosene actually gets fire. So kerosene, oil or any other substances, only when it crosses certain amount of temperature they catch up fire. So the lowest temperature or the level at which they catch fire is known as ignition temperature. So this petrol, kerosene, diesel, all these kind of substances have very less ignition temperature. So the substance which has very less ignition temperature are known as inflammable substances. Because these products have very less ignition temperature, even slight increase in temperature will cause fire, will cause combustion. So that's why these kind of substances should be handled very carefully. That's why these kind of substances are known as inflammable substances. Example for inflammable substances is petrol, diesel and kerosene. So you can even give various other petroleum products as well, because these kind of products have very less ignition temperature, which should be handled very carefully. because even with a small increase in temperature, these kind of products will easily catch up fire. You might have heard about fire extinguishers. So what does this fire extinguishers do? They actually put water on the burning substances. If like wood or paper are on fire, then water is actually poured on this wood or fire or any other kind of substances. So when water is poured onto these kind of substances which is burning with fire, actually reduces the temperature. So when temperature of these substances reduces below the ignition temperature, then these substances stop catching up fire. So whenever a substance has catched fire, when water is poured onto that substance, temperature of that substance is actually getting reduced, because when that temperature is reduced below the ignition temperature, then that particular substance will stop catching up fire. This is how fire extinguishers work. So in fire extinguisher, they actually reduce the ignition temperature of a substance. So sometimes you might have seen fire extinguishers, they will use some gas. So that gas is actually carbon dioxide. So you might have seen so many cylinders kept in various other buildings, various other offices and all. So in this cylinder there will be lot of carbon dioxide which is filled in form of liquid. So when this CO2 is released out of this cylinder, this CO2 comes out as a gas. This CO2, when it comes out as a gas, it actually goes and covers on the surface of the substance which has already got fire. When the carbon dioxide molecules will start covering up the substance will have lack of oxygen supply, because when carbon dioxide molecules are only surrounded this substance, so there will be lack of availability of oxygen and further burning of this object will get stopped, so that fire which is already there on this substance gets extinguished because of this CO2 coverage on that particular substance. So that's why lack of oxygen happens for that fire to burn more. So that's why fire gets extinguished by this CO2 molecules. So now you know that fire extinguishers sometimes use water and sometimes they use CO2 gas. Why sometimes water is used and why CO2 gas is used sometimes? Because water is more than enough for wood, paper kind of things. But when you have some electronic gadget, these electronic gadgets will actually contain electricity. So if you try to use water to extinguish fire which has caught on these electronic gadgets, then the electricity which is present in this electronic gadgets will start flowing through that water, and wherever the water is spilled on the floor, electricity starts flowing through that water. And also the electricity which was there in this electronic gadgets is actually dangerous, which will easily propagate through the water, because water is very much good conductor for electricity. So that's why water is not used to extinguish the fire which is caught on this electronic gadgets. So at that time CO2 gas is actually helping to extinguish fire which is caught on this electronic gadgets. So this CO2 molecules will actually go and sit on this electronic gadgets and make these electronic gadgets less available for oxygen molecules present around the atmosphere, and hence thereby the fire which is already caught on this electronic gadgets will get extinguished, and thereby CO2 gas helps to extinguish this fire. So that's why according to the situation, sometimes we can use water to extinguish fire. According to some situations, CO2 gas is also sometimes very much useful to extinguish fire. In most of the cases, CO2 gas is only used because CO2 gas easily go and deposit on the surface of the objects and hence thereby extinguish the fire. So in this combustion there are three types. One is rapid combustion, one is spontaneous combustion, the other is explosives. So what happens in rapid combustion is that gases rapidly catch up fire and combust to produce heat and light energy. So such kind of combustion is known as rapid combustion. In spontaneous combustion, like coal, suddenly they get flames and starts burning. So when the ignition temperature of this coal is reached, suddenly they catch up fire and starts burning. So this kind of burning is known as spontaneous. So rapidly when gas molecules combine with oxygen and form combustion, at that time they produce heat and light. Such kind of combustion is known as rapid combustion. So the third type of combustion is explosives. So best example for explosives is fireworks. So there will be a lot of pressure present inside these fireworks. Because of this pressure, the temperature, the ignition temperature when it is reached for this substance actually gets exploded. When this substance gets exploded, they produce lot of sound energy, light energy and heat energy. Because of the pressure which is present in this particular substance will create lot of damage to the surrounding nature. Now you know that how rapid combustion happens, how spontaneous combustion happens, and how explosives work. The pressure which is there in this explosive is the major cause for the explosion to happen. Now coming to the second part of this chapter, that is flame, how flame is actually generated. Well, candle is burning, so this candle actually produces yellow color flame. So you might have observed why this yellow color flame is actually obtained on this candle. The carbon which is present in this candle actually gets reacted with this oxygen and they get vaporized together. So when carbon dioxide is formed, they actually vaporize into the atmosphere. So the energy which is released during the combustion process of carbon and oxygen, that energy is experienced as heat and light energy. So the vaporization which happens due to this combination of carbon and oxygen, that vaporization actually causes flame. So the carbon dioxide which gets vaporized actually generates this flame, and hence we can see some colored flame. Sometimes we can see while burning the LPG gas, we get blue color flame. Different kind of substance which is present in the fuel, that substance when it reacts with the oxygen, the electronic levels which is present while the combination happens between these chemical atoms, so because of that different colors you can observe, and we call this kind of light energy which is obtained while burning these kind of fuels as flame. So you can do a small experiment in your home. You can burn a candle, and after burning that candle, bring a glass plate on this tip of the candle. So you can just place this glass plate on the tip of this candle and you can wait for some time. So after some time, if you remove this glass plate and see, you can see there is a black color deposition on the place where flame has got burnt on the glass. So where did this black color actually came from the candle? So you might have seen that carbon which is present in this particular substance was actually getting reacted with oxygen and it was giving us the heat energy and light energy. But now the unburnt carbon which was there on the tip of this flame actually got deposited on this glass. So this unburnt carbon is actually deposited on this glass. So what you mean by unburnt carbon is that carbon which has not reacted with oxygen molecules, which has just unreacted with oxygen molecules and it reached to the tip of the flame, that particular carbon is actually known as unburnt carbon. So if you obstruct this flame, any glass surface or any other surface, the unburnt carbon go on deposit on this particular surface. So this shows that all the carbon atoms which are present in this particular fuel will not get burnt with oxygen completely. Some of the unburnt carbon will also be remained. Now I will be explaining different zones of this candle flame. So when you light up a candle, you can see the outermost zone will be blue in color. So that indicates the complete combustion of carbon, and hence the outer zone will actually be very much hottest part of the flame. So in the middle part of the flame, you can see actually yellow color will be there and there will be partial combustion of carbon. Hence the middle part of flame is actually moderately hot. So at the bottom part of this flame, it will be very much lesser heat because there is very much unburnt wax present in that bottom part of flame. So that's why this bottom part is less hot and this middle part is moderately hot and the top part of the flame is hottest part, because at the outer zone of this flame actually complete combustion of carbon takes place. Hence there will be a lot of heat energy present in this outer zone of the flame. So in the middle zone of the flame, there will be moderate hot because the combustion which happens at middle zone is a partial combustion of carbon. So this is actually a schematic representation of a candle. So if a question is asked in examination to draw the schematic representation of a flame, then you have to write the diagram of this candle and you should explain the different parts of the flames of this candle. So you can neatly write this diagram and explain in examinations. So now coming to the next concept in this chapter, that is fuel. As I explained before, fuel is actually those substances which are available for combustion. So in my previous chapter you might have studied about coal and petroleum products. So this coal and petroleum products actually acts as fuel, because this coal and petrol easily catches fire with less ignition temperature, and hence combustion happens very easily, and we can use that energy for our different energy for our different fulfillment of energy requirements. So here these kind of substances which has very less ignition temperature and which are very easily combustible and which can be used for our fulfillment of energy requirements are known as fuel. So there is one more concept in this chapter, that is known as calorific value. So what do you mean by calorific value? So now you know what is fuel. When 1 kg of fuel is actually burnt completely, how much amount of energy it has released into the atmosphere is actually known as calorific value. The energy which is released when you burn this kind of fuel is actually indicated in the SI unit joules. So how much joules of energy is actually released after burning 1 kg of substance is actually the calorific value of that particular substance. For example, if you take petrol, if you burn 1 kg of petrol, how much energy is actually released? So that energy which is released per kg of burning of a substance is actually known as calorific value. Joule per kg is the SI unit for calorific value. So that is how much energy is actually released when 1 kg of substance is burnt. Now let us see what are all the disadvantages of burning these kind of fuels. So the first disadvantage of burning these kind of fuels is that so many fuels, when you burn, there will be lot of unburnt carbon which is released into the atmosphere as such. So this unburnt carbon actually causes respiratory issues in most of the human beings and also in most of the animals. So this unburnt carbon is also very dangerous, which gets released into the atmosphere. So when there is partial combustion or incomplete combustion, then there are chances of more carbon monoxide getting released into the atmosphere. Carbon monoxide is comparatively more dangerous than carbon dioxide, because this carbon monoxide is very much harmful for human beings' health and also plants and animals' health. So that's why release of this carbon monoxide also happens when there is partial or incomplete combustion of carbon of the fuels. Coming to the third disadvantages, when CO2 and CO is released into the atmosphere while burning the fuel, this CO2 and CO actually increases the normal temperature of Earth. When normal temperature of Earth is increased, then that leads to the global warming of Earth. So the global warming which takes place on the Earth will be actually responsible for the melting of various ice glaciers, and it is also responsible for rise in sea levels, and there is lot of environmental imbalances takes place because of this global warming. So to avoid this global warming, we have to reduce the temperature, normal temperature of Earth's surface. So when we reduce the temperature of the Earth's surface, so then these kind of effects which happen due to global warming can be avoided. So to do that, we have to actually reduce the emission of carbon dioxide and carbon monoxide into the Earth's atmosphere. For that, we have to look for any other alternative energy resources. Coming to the fourth disadvantage, we get lot of acid rains, because when this sulfur dioxide which is released into the atmosphere, this sulfur dioxide is released into atmosphere when coal and diesel is actually burnt. So this sulfur dioxide which is released into the atmosphere, the oxides of sulfur and the oxides of nitrogen actually gets combined with the water molecules present in the clouds, and then when the rain comes to the earth, it comes in the form of acid rains, which is not a good sign for living beings which are living on this planet Earth. Now we have learned so many disadvantages of using coal and petroleum products as fuel. So you will get unburnt carbon, you will get carbon dioxide and carbon monoxide released into the atmosphere, increased risk of global warming, and also acid rains is one of the other disadvantages by burning this coal and diesel. So after seeing all these disadvantages, now you should think what and all things we can adopt to actually solve this problem. One major outlook is that you should actually focus on the alternative energy resources like solar energy and wind energy, so that we can avoid the amount of carbon dioxide and carbon monoxide getting released into the atmosphere of the earth. So this is all is there in this chapter, combustion and flame. So I have explained what is combustion, and I have explained what is flame, and I have also explained what is fuel, what is ignition temperature and everything. Now we have also learnt about disadvantage of using coal and petroleum products as fuels. So this is all is there in this video. In my next video, I'll be solving the exercise questions which is there in this particular chapter, that is combustion and flame. So after seeing this video, you will get an idea about combustion and flame. So you can easily solve the exercise questions. If you feel difficulty in solving that exercise problems, then you can refer my next video where I'll be uploading the solutions for the exercise questions which is there in this combustion and flames. So please watch these two videos to get better idea about combustion and flames chapter. Like this, I'll be uploading more and more videos of physics, chemistry and mathematics starting from 8 to 12 standard. So please do subscribe to my channel and stay tuned with my channel. Thank you.